Hello everybody, welcome back to the workshop. Today we're just mucking around with some stuff just for fun, for no other purpose. This, I think it's a rotor, is that what you call it? It's out of an angle grinder. The angle grinder broke a couple of years ago. God knows why I kept this, but the other day I had an idea. So anyway, let's see if I can get it to work. This has still got the bearings on the ends. I've just got a piece of wood here and drilled a hole through the center of an old speaker magnet. And you can see if I get a piece of steel, it's not an overly strong magnet, but a magnet all the same. Drilled a couple of holes here, strategically spaced. I've got made a little block here, turned a peg on the end so that'll go into the hole, something like that. Another one on the other side. There. They're all pretty neat, there's no slop in the holes. And this one's got a hole that fits into this bearing here, and the other side, different size bearing, but it fits in there, like that. Let me just put it all together. So now that's all together in there, and that spins there nice and freely. The magnet clears it. You can look through here by a couple of millimeters. Magnet clears the rotor down in here. That's a little 12-volt battery. Obviously the angle grinder was originally mains powered. Here in Australia it'd be 240 volts. I just need a couple of bits of wire. I haven't actually tried this yet, so it'll be interesting to see what happens. These little contacts here all line up with different coils that roll around inside there, coils of wire. So if I can find the right two to touch at the right time, it should make the motor spin. Just to give you a full description of what's going on here, each of these little segments is connected to one end of these coils that go around in here. See, coil going around in here, round and around and around. And on the other end, where it comes out, it connects to another segment. As each one of these coils gets a contact, it creates an electromagnet. And the electromagnetic field around one of those coils wants to align itself with the magnetic field of the stationary magnet at the bottom here. So the rotor turns a bit. As it turns, it moves to the next coil and creates a magnet on the next coil, and then around it goes. So it's just a chain reaction around and around and around as these magnetic fields change from coil to coil. Well, that's interesting, isn't it? You seem to have to get them fairly close together if I don't short the battery out. Like something like that. And the closer you get, if you can see past my fingers, the closer you get, the faster it seems to go. Anyway, I think the answer to that is yes, it will run. Hope you guys got something out of that. Maybe you can run off and build something simple with your kids, teach them how electric motors work. Anyway, I had fun doing that. Now I'm glad I didn't throw that thing out all those years ago. I think we'll leave it there. Thanks for watching, guys, and we'll see you on the next one. Can't really see you. I pulled the 9-volt battery out of this little RPM tester, tachometer. Let's see if I can get it to go with that without getting my fingers in the way. I can, but not as fast. So if you want to try this with your kids, you don't have to scare them with a 12-volt battery. And I think that's an adequate demo if you just want to demonstrate the principles behind why a motor spins. These things are called swamp hens. We call them wild chickens. See a couple of little ones up there. Jump splash.